Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're going to continue our manufacturing series, and today we're going to look into 3D printers. So let's dive right into it. Well, first we have to understand the manufacturing process that we employ currently. Basically, anything you touch, there is a very good chance it has been manufactured. So how the heck we do it? Well, most of our manufacturing process is what we classify as subtracting manufacturing process. Basically, you take a big block of material and you remove things out of it until you get your final product. Think of it this way. Let's say you take a marble and you carve out a statue inside it. So generally, your statue would be smaller than the final dimensions of the block that you started with. So same we do with almost everything. Basically, let's say your engine block, it's never like oh, okay, this is the engine block, that's it. You will start with like a big giant block of aluminum or steel, and then you will mill out whatever part you don't need. So that is what we classify as subtracting. Basically, you're starting with 100 and you're removing things until you get your final part. Now, by definition, by its own inherent design, you can see it creates a lot of junk. It has a lot of wastage. Now in car industry, it is such a big investment that people try to recover it. Basically, if the machines would be linked in such a way that they will have an automatic cleaning system, they will clean out the chips and metal and all that and remelt it, so they will recover some of the money that were invested in the alloys and metals and all that. So lot of wastage. On top of that, it is not suited for smaller run, because all the machines that can do that kind of stuff, they are ludicrously expensive. So price per basically you have to recover the capital cost that you put into that machine and the running cost of that machine. So let's say that put X, so your product must be allow you to recover X. Now only if you did that directly, like one to one, your car will be more expensive than Ferrari also. So what they do is like they will spread the cost out over multiple things. So let's say in case of Ferrari, they are assuming, let's say they bought this machine, it's supposed to allow them to churn out, let's say 10,000 vehicles. Now again, you can understand the price of Ferrari, but let's say you have Toyota that is making something like mass production car. They are dividing the price into many small things. So that's how they allow you to buy a part for very cheap price, because they are diluting the basically cost. And this is what we call economy of scale. Basically, you take a very expensive machine that makes hundreds or something, and then you each hundred you will charge a bit more, so you can recover the cost of the machine. So that inherently makes it very hard for small run equipment. Basically, let's say you only have to make 10 piece, 20 piece, or a few thousand pieces. So it's very bad for that. Now you can easily see this reality in your day-to-day life. Let's say you check the price of basically mobile phone. It's very low, relatively speaking. What amount of technology it has is very low. Now look at the price of audio equipment. Let's say something that I'm using here right now, Zoom H1N. Okay, it has nothing that is even equivalent to its cost. Basically, if I take the same amount of money I poured into this versus the same amount of money I pour into a mobile phone would be like a freaking computer, and this barely has any chip. It does not even have color display. Why the heck it is so expensive? Because mobile phone is expected to sell in millions of pieces, and that's a flop mobile phone. That it only sold few million. That's a flop mobile phone. Like it's supposed to sell like 30 to 80 million, where you're like okay, that's like we are moving some pieces. iPhone sells in hundreds and 200s of million. So that's the reality of it. The less you sell, the more expensive part becomes. Now custom parts, let's say you are talking about something design or something unique, that's ludicrously expensive, because you might as well have an individual do it. And this you can easily see in BMW specifically, when they have chalk lines on their high-end cars. Those are ludicrously expensive, because custom parts, simply machines cannot do that. It's not that machine cannot do this, that if you bought that machine, you must make enough of it, otherwise the cost of the machine would be like your loss. And if you design a machine that can do multiple things in the same time, machine would be idiotically more expensive. So that is why custom parts are much more expensive. Now what about plastics are super cheap, and like let's say electrical box or something like this. How the heck plastics are made in such a wide variety and cheap material? Well, they employ two things. First thing is they take plastic grains basically, and they screw tight it. They put it in a screw and then they tight it. That heats it up, melts it up, and then they extra heat it. They put some extra energy into it, basically a lot of heating element, and they melt it to such a degree that there is no air gap, nothing. Then they inject it into a mold. This is what we call injection molding system. So you will have an injection that will send hot molten plastic. Now this part is super cheap, but relatively speaking, you can build it in your home. Now when you're coming to mold, now that is the expensive part. To give you a context of that, like if you try to find out the cost of one Lego brick itself, that's it, like just one Lego brick, it's barely $1, barely. Like practically speaking, it's 1/10 a dollar, but you get the point. Now here's the mold that was needed to make that that part would be like millions of dollars. Now you're like, why it's so high? Well, think of it this way: a river can grind away a stone. So how much damage a hot molten plastic under high pressure will do? So that's the whole point. The mold has to be made out of the highest quality material that we have, and it has to be temperature stable, so it can actually withstand the heat hot plastic. Otherwise it cannot be like, oh, it's expanding or contracting. No, it must be temperature stable. On top of that, it must be precise also. So like that's how Lego makes sure that one Lego fixes with another. All these things combined, basically this injection part is super cheap, the mold part is super expensive. So the only way they recover the price of it, they use the mold until the last price. So they will produce millions of it, then they will make a profit on the system. So this is our current manufacturing. Either it's subtractive or mold based design. So both of them really don't like to be in small run or in what we call custom sets. Both of them will be very expensive for that. So how does a 3D printer break this kind of limitation that we have been following for around 100 years? Well, CNC comes to our rescue. Computer numeric control. Basically, it's a machine that allows you to control the machine based on computer commands. Quote unquote G code are generally used for controlling your printer. Now, all it is doing is basically allowing you 3-dimensional control: X, Y, Z, whatever have you, those axes keep flipping. So you have a computer that can control motors, control a physical dimensions of things, like where the print head is and all that. So that is part number one, your CNC. Part number two is you take a plastic filament, whatever it may be, PLA or other architectures, even some carbon fiber stuff is available. So you take the filament and then you melt it into a reality object. Basically, you take you draw it layer by layer. Same way you draw with a pencil, you are just doing it in 3 dimensions. Basically, a pencil, think of it this way: you penciled it in one layer, then you put another paper, then you layered it another, something like that. Now you can easily see, if you make a 10-gram object, let's say it's a 10-gram object that you want to make, 10-gram toy, you will only consume 10 gram of filament. Again, little bit more because you want a bit of support material or a bit of wastage for shrinkage and all that. Again, it is additive by its own definition. So let's say you make a 2 kilo part, you will consume 2 kilo object. It's not a negative where you're like, okay, how big is this Thanos head that I want to print? Okay, is that big? So buy an object that is that big. So it will be hundreds of kilo, and then you will grind away everything, and then you will be like, okay, this is 10 kilo. I wasted 90 kilo. So you can understand that it is additive. That is why it can work on such a small, 2 kilo, 3 kilo. You go to any people who deal with a CNC machine, like 2-3 kilos is nothing for them. Like just to make a small object that you can handhold, they will grind away that kind of material. So that is why 3D printers is such revolution, because it's additive. It's not removing things, it's adding it. So what about the cost of this magical thing? Well, it's very cheap. How the heck is so cheap? Well, the first comparison that you will think of is basically CNC mill. Now, CNC mill is very expensive because CNC mill has to design something that is precise and strong. Now, why the heck it has to be strong? Well, think of it this way. If you have a laser diode that is cutting things, laser is not going to give you any feedback. You have water jet, there is no feedback on that. Now, when you are talking about CNC mill, where there is a spindle that is rotating something and there's physical contact, there is a kickback. Try to drill on something. Try to drill on a hard thing. You will find your motor torquing reaction would be harder, what we call kickback. So your CNC machine has to be strong enough to handle that kickback. Now, handling it is not that big of a deal, but handling it with precision, that's like wielding a 10 kilo object on 1 micrometer precision. That's very, very expensive. That's what the primary reason of CNC machine being so expensive. Now you can see all the CNC machine, basically 3D printer that are available in the Alibaba, Banggood and things of that nature. They are very lightweight, like they are barely 12 kilo, 13 kilo. You try to make a CNC machine out of it that can grind away even something as low density as Delrin, it will simply break apart. Now again, it will not break apart as break apart. You have to do very slowly, so it kickback is low. So that is the whole reason. Inherently, it does not require as kind of reinforcement as a normal CNC machine, milling machine. Then we come to the aspect, because of the hype that it was created in 2010 and all that. Again, 3D printer is very old technology. It's just that it came into public conscious in CES 2010, and it's not that before that it was not there. It slowly started to catch up steam, and people started thinking this will be the next revolution, and it became a lot of option was available in markets. If you want to 3D printer on $100, I can guarantee you there is one available for you for $100. You want $200, you got $200. You want $300, you got $300. So you can understand, lot of option, lot of competition, lot of lower prices. And on top of that, like running this is not that expensive because the filament cost is not that high, because we do know how to mass produce, and these filaments are made in the same injection system. Instead of mold, there is just a pilot hole where they're making sure the diameter is perfectly accurate, and that's it. They are spooling it, so you can understand it is very cheap. Like even though you are buying this in kilograms, they are barely few dollars. Heck, to give you a context, this price of this is more or less same as a cartridge or a toner in your laser printer. So what did it do? Well, in prototyping, it changed the world. Basically, prototyping is something that when you take a design and you make a dummy out of it, basically, be it a mechanical dummy where you can rotate things, smooth things and all that, or maybe it's just a placeholder, like, okay, this is how it's supposed to. It could be done in multiple ways. You can draw it 1-to-1, basically it will be this big. In reality, once you do the final product, your 3D print will be this big. Or you can do it like 20-to-1, where okay, this object supposed to be this big, you're gonna make us this small. So both are done, and this was necessary step. Like engineering relies on this kind of scenario. If you go to any car manufacturing, you will see there are people whose sole job is to make models, whose sole job is to design a dummy bodies and all that. So prototyping is not something that you can overlook. If you want to make a product, you have to make a prototype. So prototyping industry loves 3D printer, and they ran with it. Like 3D printer really helped them a lot because it's flexible and adaptable. To give you a context on that, let's say all you do is design cup holders, pen holders, or things like low level stuff. You can have a normal 3D printer and you can just YOLO it. But let's say you want to design something with more moving parts and complex thing, and you're like, okay, if I try to do this in one go, problem is my plastic will weld itself, or I have to use a lot of what you call support. Basically, if you are trying to make something big, it has to support its own weight, so you have to do the support. Again, you don't want to do that. So what people do is generally they will have multiple head printer where they will have multiple extrusions, and they'll use another support material. That support material would be soluble, so you will make your 3D printing, like say this jet engine, from normal what you call PLA, and then you will have a support material which will dissolve in either acetone or alcohol, and use that as a support material. So once you are done, instead of snipping hundreds of clip points, you will simply dunk it in a bath, whatever it may be, acetone or alcohol bath, and it will dissolve it away, and voila, now you have a very complicated part that flat out was not possible until you develop the final machine. So that is very flexible. So prototyping industry loves this. Now, then why did it fade it out? If I started in 2010, this is 2020, we are approaching, and 3D printer is not in every home. Why the heck that happened? Well, first you have to understand the parts are inherently weak. They are weak on a physical level, they are weak on a chemistry level, they are just too damn weak. Basically, this is an electrical box, and you can take a drill to it and it will survive that. And you try to do that with your 3D printer, good luck with that, basically. Because why it is inherently, because how we are laying it down, we are laying it down layer by layer. So by definition, if you pull it, it's indestructible. You compress it, it's indestructible. The moment you pull it apart, like in the layer direction, yeah, it's gonna split apart like this. It inherently does not have the same adhesion that it has laterally. Basically, it's like plywood. Actually, worst kind of plywood, because generally plywood, they make sure you have some going horizontally, some going vertically, things of that nature. Like how you see carbon fiber, they never have every strand going in one direction. They have crisscrossing it. In this, you have only one direction. So it's very strong if you are pressing it down. It's very strong if you are compressing it from side to side. Basically, layer dashing is very strong. The moment you pull it apart, it's like it will pull apart same way a copy does. So it's very weak, inherently weak. On top of that, in terms of precision, let's say you are talking about injection molding, it's precise to nanometers basically. That's how Lego is ensuring that you buy a Lego in 2000, then you buy a Lego in 2010, it will still fit with each other. They are ludicrously precise. When you're talking 3D printer, try to make a Lego out of it. It will never be as precise as a proper Lego. So flat out the precision. So if you want to make a small part, it's not good enough. Like it's not precise enough. Let's say this television has a plastic clip that is holding the circuit boards in the back. If I try to make something that small with a precision needed for that kind of thing, it will simply not work. It's not precise enough. On top of that, it is super slow. So this is the one aspect that the moment anybody buys a 3D printer realizes, 3D printing takes time, and it takes as much as 19 hours, 20 hours. Sometimes if you see many YouTubers who build tanks out of 3D printer, they are like, yeah, it took 1 week to print. So you can understand it's very slow. And CNC machine, even though it's subtractive, even though it's removing that, it can do that 10 times faster. And CNC machine is a mass production machine. So flat out, the parts are weaker. You cannot expect as kind of precision and all that, because inherently the plastics are unstable. They cannot use high strength plastic. Why? Simply because you will have a hard time melting it in order to do the printing in the first place. So that's the reality. And in the final thing that people realize as time went on, it's not that useful. Again, how many cup holders do you have? How many pen holders do you have? It's like many people who are on YouTube and making things, they are just making gimmicking things. Like, it's a good thing, it's a fun entertainment and all that. It's not something that you will do every day. It's like buying a printer for your home. It's like, do you really print every day? Do you really print 100 pages per day where you like, that is expected out of your printer? So that's the reality of it. For prototyping niche cases, it's awesome. For everything else, it's like no. That is why, like, in 2010, like every news channel was like, 3D printing is gonna change the industry and all that. The idea was now the car manufacturing companies, whoever is manufacturing whatever, like they have plastic parts, they will manufacture in 3D printer, and the benefit would be they never have to quote unquote stock up. Where they're like, I told you the mold also has a limited life, so they want to make sure they push it to 100%. And whenever they have to apply support, they hope they have the repairing part, defective part. Like, let's say you broke a plastic part in your car, that part's supposed to be somewhere in the warehouse, so 3D printer should bypass that. Again, in reality it would not. It simply is not strong enough, not accurate enough, and it's super slow. So like you send a command, and if it's a complicated part, they will be like, yeah, we'll be printing in 38 hours. Like, you can get it shipped all over the planet in 38 hours. So that is why it faded out. Like, it has its use cases, it has like it's a fun thing to have. Heck, it's a very good school project to build with your kids and all that, but not a useful one. Like, it did not become as useful as CNC milling machine, EDM machines, or water jet cutting machines, or laser cutters. It's not that. Now in the next video I will talk about 3D laser printers, basically 3D metal printers. So I hope you liked it, learn from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.